Here's an assortment of problems, and in each of these instances what I'm going to do is I'm going to find out the negative charge on each side and then figure out the charge on each cation. Now I know in some instances you really don't need to do that, because if they're type 1 cations we already know what the charge is going to be, but I think it's always good to treat these as if you don't know whether it's going to be a type 1 or a type 2 cation until the end, and then just figure out the charge by the method I'm going to show you here. So if you've got Li and Br, we just got one Li and one Br. The charge on Br is -1, there's one of those, so total negative charge is -1, which makes the total positive charge +1, which makes the lithium have a positive charge. And the name of this would then be lithium bromide. Now then we can go ahead and figure out whether it's a type 1 or a type 2 cation. We see that lithium is in group 1, does indeed have a +1 charge, so we don't need to put the charge in the name because lithium always has a +1 charge. So the anion and cation we form here are going to be lithium plus and the Br minus. In the next one, BeI2, that's 1 Be and 2 Is. I has a -1 charge, it's in group 7. Total negative charge -2, total positive charge +2, and Be has a +2 charge. So the name of this would be beryllium iodide. Now the charge on beryllium is going to be 2+, and it's in group 2, so there's no need to put the charge in the name because beryllium is always 2+, and the ions would be Be2+ and I-. That's the ions we use to get the name. Over next one, AlF3. We got aluminum, and we got F, we got F, we got F. F has a -1 charge, it's in group 7, negative, 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 -3 here, total positive charge +3, aluminum has a 3+ charge then, and the name of this would be aluminum and then fluoride. I look over here, I see aluminum is in group 3, it always has a +3 charge, it's a type 1 cation, so there's no need to put the charge in the name. Okay, and the next one we've got PbCl4. That's 1 Pb and then 4 Cls. Cl is in group 7, has a -1 charge, -1, -1, -1, -1. Total, -4. Total positive charge, +4, which makes the lead have a +4 charge. So the name of this one is going to be lead -4 chloride. Now the charge had to be put in the name here because lead is not one of these type 1 cations. Lead can have more than one possible charge. It could either be 2+ or 4+, and we need to say in the name which one it actually is. So this one becomes lead-4 chloride. And the ions responsible for the name would be lead-4 and the Cl- like that. Alright, looking at the next one. Looking at the next one, we've got SN3N2. That's going to be 3 SNs and 2 Ns. The charge on each N is going to be -3. Total is -6. That means that the total positive charge here has to be +6 to match. The charge on each SN has to be 2+, so we get to +6. The name of this is going to be tin 2 nitride. Now we have to put the 2 here because the ions we used were tin 2, and tin is not one of these type 1s, it's a type 2 cation, which means I have to put the charge in the name. Tin could be either 2+ or 4+, so the 2 goes in here, so tin 2 nitride, and the ions responsible are a tin 2+ and the nitride ion. That gives us the name.